have built as part of the GEMA 4 hackathon Agentic consultation system in which it's a simple single agent agent based system where we are using it's not a multi-agent system but a single agent system where we basically empower doctor to leverage the conversation they have had with the patients and the patient's history to arrive at a AI generated prescription in which they can refine, fine tune, and then they can share it with the patient. And this prescription should cover uh, the the diagnosis, the medicines, the notes which the patient should take care of, along with the tests which the patient may need to go undergo through if the diagnosis, if the issue is not resolved within some time uh, once the medicines are prescribed. So this system involves three major microservices: a doctor agent, patient agent, and a medical manager. So doctor agent is a AI agent which provides APIs for the doctors. Patient agent is a patient microservice which provides APIs for the patient. And medical manager is a centralized backend service which takes care of storage of the data, the records, doctor information, patient information, the consultations, the consultation history, uh, the memory for each patient, and the messages. Now, how does the architecture look like? So we have a front-end apps which is built using Streamlit, which is allowing patient and doctor to chat with each other using a real-time WebSocket-based app. And in this flow, basically, Doctor Agent is the component which has integrated the GEMA 4 model, where it is calling the Google AI Studios APIs to to do the inferencing based on the chat messages and a system prompt. And since this is a simple hackathon project, so we have kept a simple SQLite database for storage of the data in the local machine. So we'll and how does the typical consultation workflow look like? So basically, a patient and a doctor will be registered on the platform. A doctor will accept available consultation. Both patient and doctor will chat on the platform, and once doctor has received sufficient information from the patient, the doctor will go ahead and use AI to generate a prescription. And this is where the gamma 4 model will come into picture to generate the prescription based on the chat history and the patient memory. And once the prescription is generated, so these information will be updated, and then the doctor can fine tune the prescription and then share it with the patient. So now we'll go and see a live demo. So we'll start with the live demo now. So I will show you some of the consultations I have created, where we have basically John 1 who said that there's a sore throat, and for that we have got this prescription generated. And I will also show you this is what the patient sees as of now. And what we'll do is we'll create another patient. I'll just sign out. So let's say we'll create michael@test.com. So we'll register this user. So we'll say that this user has been facing he has, let's say, high fever of 102 along with wet cough, and since last 3 days the fever is coming and going but not fully but not see any improvement. So a consultation has been created. Now we'll go to Jane Doe. We can see that there's an unassigned consultation that has been assigned. Now we will see there's a high fever of 102 days. So we will ask, is there any body pain? So the doctor has asked if there is any body pain, and we will just see that let's say we'll reply that facing back pain and not able to sit properly. So we have received. Now we'll ask if you have any medical condition like diabetes. So we can say that I am pre-diabetic with HbA1c of 5.9 tested 1 month ago. Now with this we will ask, this is where we will ask AI to generate the prescription. So the prescription generation is in progress. So as part of the prescription generation, it will check that no prescription exists. Now it is invoking the Gemini model so that it can generate the prescription for the user. So the prescription has been generated. It is it has given some possible options. The AI has suggested paracetamol along with hydration, which medicines to not take. So it has also suggested some tests to get done. Now here we'll see as of now this is not showing, but if I just go back and come back here, I'll just refresh this once. So here we can see that there are certain, we can also modify some of this. So for example, let's say if I say कि malaria is not a valid reason, so I'll just remove malaria from here, and let's say this is also, I will say, is not related. Because I have some context. So I have edited this, and I will say CBC, I will ask not to get malaria testing done, because let's say I am aware that malaria is not common, and urine culture also not required. Now what we'll do is with this I will ask to send the prescription. And now if I check here, the prescription has been shared with the user. And I will also ask that let's say so this is there. So we'll say I got vitamin D test done, and my vitamin D was below threshold. So he has sent that. So what I will do is I will ask it to review impact of vitamin D deficiency and generate updated prescription. So we have applied a refinement, and again the model is in progress, and we'll see that the model is working on generating an output. So as of now we can see that uh, it has some of the items I have removed, I had cleaned up, so that this is what is showing, and we'll see that once the refinement is complete, the prescription will change. So the prescription has been generated again. So now we can see the impact of vitamin D deficiency has also come into this picture. And if I just refresh this again and log in, so for Michael, I can see that the vitamin D has also gotten accounted. This was not earlier showing, now it is showing the vitamin D is there. And if I see the prescription currently seen by the user, in that prescription I can see that there is no mention of vitamin D. And because I asked something, so the prescription has again gone in draft state. Now I will republish again. So I have republished it, and now I will see again it has come, and now it is talking about the vitamin D deficiency. So this is around that, and this is how with uh, the LLM models the doctor can refine the prescription. If we enhance the input data to the models, we have a MCP server which can give us a good information about the diseases, the impact of the medicines, and if we have good patient history available, this agent can be very useful in uh, helping doctors assist and come up with a very comprehensive consultation for the patients. So that's it for the demo. Thank you.